Okay, now I want to take this idea of inequalities and I want to have a graphical representation of it. What that means is I want to take the idea of what an inequality is and make some sort of picture where when we look at it we have maybe a deeper understanding of what's actually occurring here. So let's look what it means for x to be greater than 3. So when we're saying something is greater than something else, what does that mean? And here x is basically a variable. It's any value which makes this inequality true. Just like how you have an equation in algebra. And let's just do this instead. Easier. So in algebra you might have something like x plus 3 is equals to 4. And once you do the algebra, you see that the value which makes this true is x is equals to 1. So when we're doing the algebra there, we see that there's only one value which makes that true. But for an inequality, we can have an infinite number, like as many as you want, of values which makes this inequality true. So in this case, we went from having only one value making the statement true to having an infinite number. So when we're saying that x is greater than 3, what are we saying? And why is there a difference here? If you can see, there's an open circle at 3. So this is 3, 4, 5. So as you can see, there's an open circle, and then I kind of like drew a little jagged line saying that all numbers from this point are covered. So what this is saying is that any value which is greater than 3, is which I shaded here, from here to infinitely positive, makes this statement true. And you can kind of just put any number and you can see that's true. So let's say you put in 4 here. 4 is greater than 3. Any number to the right of that. 5 is greater than 3. 6 is greater than 3. So any value 3.33 is greater than 3. 3.141596 is greater than 3. So all these values makes this statement true. But the reason why I put a circle here at the 3 is because 3 does not make this statement true. Remember, this says greater than. It doesn't say greater than or equal to. If I put that symbol, it would be true. Because this is greater than or equal to. So even though it's not greater than, even though 3 is not greater than 3, 3 is equal to 3. But for this case, we're just going to worry about this inequality which says x is greater than 3. That's why I put the circle. Again, let's look at x is less than 3. In this case, again, I put an open circle saying that the point at 3 is not included. Because if you put 3 here, it's not true. 3 is not less than 3. But any number less than 3 makes this true. So for example, let's take 2. 2 is less than 3. That's true. Let's look at another example. Let's say we took -2 here. -2 is less than 3. So any value to the left of 3 is, I basically scribbled it in. So let's say you were going to do this from scratch. You write the number line, you write 0, 1, 2, 3, -1, -2. And you can have as many ticks as you want, how big you want the number line. I'm just going to do this for convenience. So if I wanted to do this statement, just like I said we're not including 3, so we have an open circle. And which values make this inequality true? Well, that's any value to the left of 3. So we just shade it in like that. And if any teacher looks at this on a test, they'll understand what you're doing. You're saying to them that any number to the left of 3 makes this inequality true. Now where it gets interesting is when we start talking about the greater than or equal to. In this case, we fill in the circle. Why? Because the point is included. So 3 is greater than or equal to because it's equal. 3 is greater than or equal to 3 because 3 is equals to 3, right? So in this case, we would shade everything to the right of 3. So let's say you're given some number 4 and plug it into x. So 4 is greater than or equal to 3. That's true. That's why all the values to the right of 3 are shaded in. Finally, let's look at this case over here, where we have x is less than or equals to 3. As we see here, any value to the right, to the left, sorry, of 3 makes this true. So we could have 0 is less than or equal to 3, which is true. And again, very important, this says, this dot here says that 3 is included. If it was an open dot, that would say 3 is not included, but that would be wrong, because we're saying less than or equal to. Okay, I just want to bring up one little point, and then I think we should be good. Let's talk about some terminology that some people will talk about. This way. So anytime you have greater than or less than, so anytime you have the inequality symbols, but they don't have the line underneath which says or equal to, we call these strict. Why is it strict? Because in this case, 3 greater than 3 is not true, because it does not include the equal to. For example, if I were to do 3 is greater than or equal to 3, it's true because we have the equal to, right? So a strict inequality is when you don't include the possibility of an equality, meaning that they could possibly be the same. So this is not included in this. So since it's not included, this is false. But in the inequality here, this is included. So this is true. So whenever we have the inequality symbol without the line underneath, we say they're strict inequalities. That's some terminology you might hear.